Very often you will be asked to take the integral of something that looks like a chain rule or a product rule problem. When that happens, the straightforward method of taking an integral like we did in the last section won't work at all. And what we have to do is integration by substitution. What you do is you look for something inside the function that looks like its derivative lives somewhere else inside the problem. For example, if you take a look at this guy right here, it looks like 4 to the x squared minus x has a derivative living somewhere else in the problem, and that derivative would be 8x minus 1. So let's go over the steps in doing a problem that looks like this. So it's a pretty lengthy process, and even though there's a lot of steps, the problems don't take near as long as this would make it seem to be. Step number 1 is you determine the function that appears to have a derivative in the integral and call that guy u. So if you're looking at your function and it looks like something could be the derivative of something else, that something else is u, and say u equals that. Then you take the derivative and call it du dx. So you'll say du dx equals derivative. You take that and solve it for dx. Substitute dx into the original integral. When you do that, usually things cross out, and the only thing you'll be left with are a bunch of u's and a du. Then you integrate with respect to u. Don't forget your plus c. Substitute u back into the equation, and then bada bing, bada bang, bada boom, you're done. Easy, right? Let's do a couple problems. All right, time to do some crazy problems. We have the integral of 8x minus 1 times the quantity e to the 4x squared minus x. If I give you an integral and it looks like a chain rule or a product rule type problem, that usually means integration by substitution. Okay, or in this case, yeah, integration by substitution. It's a 6-step process. Step number 1 is look at every part that you have, okay? And it looks like I have 3 parts. I have an 8x minus 1, I have an e, and I have a 4x squared minus x. See if there looks like a function that has the derivative living somewhere else in the function. If I take the 8x minus 1, it doesn't look like I have a derivative of it floating around. However, if I take the 4x squared minus x, and in my head do the derivative of that, which is 8x minus 1, 8x minus 1 lives right there. So I'm going to set the original looking equation as my u. So u is 4x squared minus x. Not e to that, just that part. I take the derivative, and in this case, the derivative is going to look like this, du dx. Okay, this is step 2. Take the du dx, which means take the derivative of u with respect to x, and that's going to look like 8x minus 1. I take this guy and solve it for dx, which is a swap. So I'm going to multiply both sides by dx. So that looks like du equals 8x minus 1 dx. And I'm going to divide both sides by 8x minus 1. In the future, like I said, we're just going to do a swap. Okay, so what I have is I have du over 8x minus 1 equals dx. Now I take that dx, okay, and I replace that dx with that guy right there. So I haven't done anything yet. I replace that dx with that guy right there. So I have the integral of 8x minus 1 e to the, and you know what? 4x squared minus x is the same thing as u. So I'm going to replace u, or that guy, with u. And if you're wondering why, you'll see why. Dx now becomes du over 8x minus 1. Oh look, 8x minus 1 in the numerator. Oh look, 8x minus 1 in the denominator. Cross them out. What that leaves me with is the integral of e to the u du. Now, if I were to leave that u as 4x squared minus x, if I were to leave it like that and have, say, the integral of e to the 4x squared minus x du, I wouldn't be able to do the problem because that u says I'm only allowed to integrate with respect to u. But since I changed that to u, now I can do it. Let me see, the derivative of e to the u is e to the u plus c. Now, in the original problem, did you see any u's? No. So I have to turn u back into that guy. So my final answer is going to be e to the 4x squared minus x plus c. Okay? So that's my 6-step process. My first step was figure out which guy looks like an antiderivative. It was that guy, call it u. My second step was find the derivative of u, find the du dx. My third step was solve for dx. My fourth step was to take that dx and substitute it into the original dx in the original problem, okay? And while we're at it, turn that guy, turn anything that's a u into that. Now I take the integral, we'll cross things out in this case. Now I, fifth step, integrate with respect to u, and the last step is substitute u back in. Awesome sauce. Awesome sauce. 2 more problems. All right, integral of x squared times the quantity 3 minus 10x cubed to the 4th power dx. All right, we have one of two options, a really good option and a really bad option. The really bad option would be me taking this guy, foiling it out 4 times, and then multiplying it all by x squared and integrating that polynomial. Bad idea. What I want to do instead is take a look at what I have, notice that it looks very chain rule-y, very product rule-y, and think, oh, I could just do integration by substitution instead. Let me see if I can find something in here that looks like it potentially has a derivative somewhere else floating inside. So it looks like I have an x cubed, and taking the derivative of something x cubed is going to give me x squared. So let's give it a shot. Let's take all of that and make that my u. Now, if you're wondering, well, why can't I just take that part and call it u? Why do I have to include the 3? Well, if I include the 3 and I take the derivative, which is the next step, it just goes away, and life is good. So I have that going away. I have negative 30x squared. Now I solve for dx, which involves a swap of these two guys. Remember in the last problem, we multiplied both sides by dx and we divided both sides by whatever was over here, and we just ended up finding out that all I had to do was go like that. So du over negative 30x squared equals dx. Now before you freak out and you're like, well, hold on now. This isn't the same as that. These two aren't the exact same. No, but the number in front doesn't really make a difference in the end, and you'll see. Now what I do is I take that guy and I plug that in, and I change whatever I let my u equal into u. So now what I have is I have the integral of x squared u to the 4th times dx, which is now du over negative 30 x squared. I have an x squared on top here, I have an x squared on the bottom there. Those two cancel out. If I wanted to, I can bring that negative 30 that lives in the denominator, bring it to the front of the whole thing, then write out the integral and say the integral of u to the 4th du. Okay, so if you're like, whoa, what just happened? To get from here to here, I went back to the original problem and I turned that guy into u. I turned that guy into du over negative 30x squared. Once I did that, I had an x squared floating around in the main part of my problem and an x squared floating around on the bottom part. So the x squared and the x squared cancel out. I have a negative 30 also living on the bottom part. Bring that out and put a 1 on top because it's a fraction. And now I have that, which I can integrate. So 1 over negative 30, the integral of u to the 4th is add 1 to the 4 and make it 1/5 out front. And don't forget your plus c. Negative 1/30th times 1/5 is negative 150th. 150th. U was that guy, so let's bring it back in parentheses. 3 minus 10x cubed to the 5th plus c. And now we're going to FOIL that out 5 times. Kidding, I'm kidding. Oh boy, so much fun. So much fun. Integral of x over square root of 1 minus 4x squared dx. So it looks like I have product rule, not product rule, but more, chain rule-y, quotient rule-y stuff. So that's going to mean that I have to pick a u and do integration by substitution. I have one of two options, x or 1 minus 4x squared. Well, the derivative of x is 1, and that makes sense. However, if I took the derivative of this whole thing on the bottom, I get 8x. And 8x may not exactly be x, but I'm going to give that a shot. Again, like I said in the last problem, if you pick the wrong u, try it again. Maybe try the other object or more of that object, and usually it will work. I picked my u. The derivative of that u is nothing minus 8x. Swap du over negative 8x equals dx. Change that. I get the integral of x over the square root of u. Instead of dx, du over negative 8x. Bada bing, bada bang. So this is what I'm going to do here, and this is where it's going to get potentially confusing, okay? There's my integral. I'm going to, first off, bring the negative 8 on the bottom out and make it a fraction. So that part's gone. I have 1 over the square root of u. And I think not too long ago, I did a problem where I had 1 over the square root of something, and I turned it into whatever that something was to the negative 1/2. And it's a two-piece thing that I can do. If I have a thing on the bottom, I can move it to the top and make the exponent negative. And if I have a square root, I can turn it into negative 1/2 in this case. Okay? Du is now living on the outside. If I integrate u to the negative 1/2, the negative 1 over 8 still lives out there. If I add 1 to the negative 1/2, my u becomes positive 1/2. And so I have to do the 1 over, add 1 to the negative 1/2, positive 1/2, plus c. Negative 1/8 times 1 over 1/2 is going to be negative 1/4. And if you're like, how did you do that? What wizardry was that? 1 times 1 is 1, 8 times 1/2 is 4. U was 1 minus 4x squared. And plus, to the 1/2. So I can make that a big square root if I wanted to. And if you left it that way, that's fine. But you know what? Let's have some fun and just write it out. That's that. These two are the same exact thing, by the way. Same exact thing, same exact thing, same exact thing, same exact thing. Same exact thing. One more. Who wants to do more problems? Me. Ugh. What an awful looking problem. Well, just like the last couple, it looks like I have product chain rule looking stuff going on in here. And there's really nothing I can do. I mean, I have stuff living inside cos x. This is not a foil looking problem. I have cosine of stuff living inside and then multiply that to that, and that's just a mess. So I have two things going on here. And that guy looks, if I took the derivative of it, I'd get that guy. So I'm going to set that equal to u. The fun thing about integrating by substitution is if it doesn't work, go back and try it again. Who sang the song, "If at first you don't succeed, dust yourself off and try it again, try it again"? Was that Aaliyah? I'll have to look that up. Take the derivative. I won't look it up. 1 minus, the derivative of ln of x. Oh yeah, 1 over x. That's crazy. All right, step 1, pick a u. Step 2, take the derivative of it. Now swap. I have du over 1 minus 1 over x is the same as dx. Go up here, replace that dx with that guy. Replace that guy with u. So I have the integral of cosine u times 1 minus 1 over x du over 1 minus 1 over x. Oh, how convenient. So they cross out. I am now left with the integral of cos u du. The integral of cos u is I could have just turned that into an s. I wasn't thinking. Sine u plus c. U is x minus ln of x. So sine x minus ln of x plus c. And that's it. So much fun. Let's do a few more.